Hi everyone, welcome to the fifth part of the tutorial on HEC-RAS 2D flood modeling. Today, we will see how to generate a two-dimensional mesh using RAS mapper. Previously, we already have our infiltration layer, and you know how to develop the infiltration layer and assign the curve number from land use and soil dataset. We already demonstrated that in the previous tutorial. So if you miss it, you can go back and check those tutorials to see how to generate those infiltration layer from land use and soil dataset. So today we'll just develop our two-dimensional mesh. Basically, those are the computational points where our computation will be conducted. So these are the steps we have already done, but the remaining step is starting from here. So first, start with creating a new geometry. So right click on the geometries and then create new geometry. You can put any name you want. I'm just giving the name as 2D geometry. You can put a space. That's not a problem. So click OK, and here you'll see layer association. If you see the terrain should be connected and Manningsen should be connected to land cover, and also infiltration layer should be connected to infiltration layer. So those are the layers we created previously, and now we just connected those layers with the geometry we just created. We don't need impervious, so just click on close. Now what you need to do, you need to edit that geometry, and you will see, okay, let me just close it and open again, and you can see all the layers. Yeah, so this, you can right click on that and edit geometry, or you can just click on this button pencil. It will just turn this geometry into editing mode, and you can see the hidden layers. So for 1D model, we work with these options, river, cross sections, this and that. But for 2D modeling, we'll just turn on our 2D flow area. And if you click on the plus sign to expand it, you can see we need the perimeter. So this is basically our perimeter, but we added this perimeter in this feature file. So we need to add it here. And you can just click on that, right click, and select import feature from shapefile. Now locate the shapefile we have from our previous steps. If you go to GIS and shapefile, and here you can see we have this as our boundary. We already used the projection, that's why I put this projection here as well. If you open, you can see the preview here, and if you think, okay, it's okay, the right layer you imported, then you can just click import and you can turn it off. So this is the layer. You can see it's basically our computational domain, and we need to create our grid size, and we need to select the grid size to create the mesh for the entire domain. But before creating the mesh, we need to modify the boundary a little bit. Like here you can see that's the inflow boundary, so it has to be like perfectly or nearly perpendicular to the stream. If you zoom in, you can see that's the main stream, but this boundary is not perpendicular, so we need to just edit it here. That's the inflow boundary coming from upstream. But for other overland boundaries, I think these are already following the high land, so we don't need to do anything. But if you think we have any inflow from the upstream, you just need to modify the boundary. And at the downstream as well, where you have the outflow from the model, we need to put our water level or normal depth boundary here. So we need to even modify this boundary as well to make it perpendicular to the stream. So what we need to do, since it is in editing mode, you can just select edit feature, and then you can just click on this, double click on that. You can see the vertices, and you can now edit. If you want, you can just delete. You can just select some of this, and automatically it will be perpendicular to the stream. If you think this is okay, you can leave it here, or you can just drag it somewhere and you can add like more point. You can delete, you can shift it here. From my understanding, for the sake of this demonstration, I think this is enough. It's looking like perpendicular, so I'm just leaving it here. And go to the outlet where we have outflow from our model. So I'm thinking we can draw the line this way. So first I can just delete. Yeah, I can delete this nodes or vertices to make it perpendicular. And if I want, I can even add more, and I can even drag it if you want. Like this way, you can drag it here. You can, yeah. So I think this is good. So we are just done with. If you want to add more point, you can just put points here. If you want to remove, you can do that as well. So that's the editing of the domain, how to edit after importing any shapefile. So if you are done with this editing, now it's time to create the mesh. So at first, we'll create nominal mesh. Everywhere the mesh will be same. Then based on the stream network, we'll just refine our mesh. Based on the roadway network, we'll refine our mesh. So we'll do that. We need to download the stream shapefile. We need to process those. I'll show you how to do that. So let's finish generating the nominal mesh. So how can you do that? You can right click on it and you can even click on this edit 2D area properties, and it is giving you this option to select the mesh size. We already know our projection system is in feet, so whatever value you can see or assign, it's in feet as well. So we can select 200 feet by 200 feet as our nominal cell size, and then we can even refine those cell size later on. So if you think this cell size is good, so you can just click on here, like generate computational points. Maybe it will take a while, so it created more than like 24,000 cells. So close it and see these are the cell size 200 feet by 200 feet. So in order to perfectly simulate and improve the result, we need to refine the grid following the stream. So in order to do that, we need to have our stream shapefile, and we need to even process these. And if you want to turn on the computational point, it will show you the points here as well. So when we'll just refine the mesh, we'll see some problems with this mesh, because there is a rule that this mesh only accept like 8 maximum edges. Like this one has 4 edges, right? 1, 2, 3, 4. But in some other cases, if we see we have more than 8 like edges or cell faces, then it will show you some error. So we need to correct those, and we'll see how to correct all the errors, and then we'll run the model. So we're done with the generation of nominal mesh, that is 200 feet by 200 feet. So the second step is to refine the mesh. So we'll use our break lines to refine the mesh, but we need the roadway shapefile to refine the mesh following the roads. We need to refine the mesh following the streams. So we need our stream shapefile. So what I did, if I go back to my GIS, and here you can see the same way I downloaded my watershed in the first video, I already demonstrated that. And I also downloaded my NHD streamline, basically the stream share files. And you can see within this red boundary, we have this stream network. So what we need to either clip the streams, those are within our domain, model domain, or if you want, you can even import the entire stream file here as well. But it's better to clip using our study area boundary. So let's investigate if these streams are actually following the terrain or the DEM. If not, then we need to do stream alignment. We have to correct the alignment, because see, that's based on the LiDAR data set. This is my stream, but the shapefile is not following the streams, right? Even here as well. So everywhere it's not following. It's not following the deepest part of the stream. We call it Tolweg. So what we need here, we need to clip the stream first, and then we need to manually edit it. So maybe it will take several hours, 5 hours, 6 hours to fix those streams. So that's basically laborious job. There is no alternative for that. But what you can do, you can, instead of editing this shape file, you can even process this DEM. You can delineate the watershed, and then from flow direction, flow accumulation, you can generate the streams as well. But still, you will have some like discrepancies in between the actual DEM and the stream shape file. So you need to manually edit those as well. For this case, what I have done, I already clipped it, and I spent like 6-7 hours to fix those alignment. And let me show you how it's going to look like. So for example, here I have the stream shape file, and see it's following the terrain. Yeah, everybody see it's more or less following the terrain. So from this shape file, you need to generate this shape file so that your model will give you accurate result. Yeah, here everywhere you need to follow because we have a road and we have a stream here. And if you want to make sure that your stream is actually following your terrain, then you are done with the process. Here we have offset here. Basically from NHD plus, it's giving you, because those shape files are based on a previous like DEM. That's why it's not even following the terrain. So it's mandatory, or it's recommended to do the stream alignment first. So once you are done with the stream alignment, you need to download. So that is my stream now. I clipped it. And then you need to download the roadway. So I have downloaded the roadway for the entire Texas, you can see, but I don't need that. So I need to clip the roadway the same way I just clipped the streams, right? So that's the roadway network. We'll use the roadway network to refine our mesh. But see, once you have a roadway, right, you have a road, you have a stream, definitely there will be a culvert or a bridge. So you need to consider that one as well. Once you have a crossing, here you can see, if I turn on the imagery, it's already there. Just let me turn off the terrain. You can see we have a road, we have a stream crossing. Definitely there is a culvert or bridge. So we need to even consider that, and later on we need to modify the terrain as well. We need to insert that. We need to take care of this structure. So there will be many. You need to manually investigate to find out if you really have any. Even here, that's a culvert or a bridge. If it is small or large, doesn't matter. You need to take care of these crossings. So there will be many, you can see. So later on, we'll just run the model. We'll investigate where our flow is basically blocking, and then we can remove the blockage to connect the upstream and downstream of a road to make it smooth connection and continuous flow to the outlet. So we'll do that. And what we do, even if you have any city or population or any community here, so we need to even refine our mesh in the second level. So we need to even download the CD shape file as well. And then you need to see if there is any, yeah, let me check. So that's the population from Tiger dataset. So these are the locations and shape files as polygon where we have our cities. See, let me turn off, and you can see we have the community. So if you have any community, you can follow the streets, and then you can even refine your mesh, because those are the important locations. But luckily for this study area, we don't have any cities, right? Any population. It's a rural area, so that's good. And roadway, we have streams, we have populations, and we have also our the structures, locations. So what I did, I created a shape file called sample cut line, because we'll just remove the blockage using a cut line. So you can see the second return of the stream. you can see that shape file. So I just use this shape file to remove the blockers from the terrain. If I turn on the terrain, you can see it's not even removed. It's showing the high ground. So we have to connect this side to this side, right? And we need to remove the blockers. So we'll use this shape file, and then we'll remove the blockers to make the stream flow from upstream to downstream. So I already identified most of the locations, and I put here, if I open my cartline, sample cartline shape file, attribute table, you can see I already defined those as culvert. And it has certain lengths, these and that, so we'll take care of this later on. But the first step is to cleave our roadway, process our streams. So the next step is we need to process those data set using a toolbox. Let me show you the toolbox. We have a toolbox here where I can even assign where is our streams and how much boundary we can assign. And for roadway, we need to assign a certain value to refine the grid. So usually we use like 50 to 100 feet to refine the grid from 200 feet. So this tool will take the input as work area, means the boundary. So this is the boundary. We have it here. And then we have the CD shape file. So we already have CDs outside of this study area. That's okay. And then the stream shape file. So that's the stream. I added the shape file. And then in the transportation shape file, I use the roadway shape file. And in the cut lines, I use the sample cut line, the same shape file and output folder. So let me change this to work area 2. And then I can, like here, because I tried that previously. Yeah, let me just give you the new folder, empty folder as work area 2. And inside that, it will generate some files. So forget about whatever we have and let's see the output. Let me go back to GIS and you can see. So this 50 means we need to have our Manning's roughness because these are the channels, right? You can see the small channels. So I use 50 feet on the left side, 50 feet on the right side to make a buffer zone where I can assign the Manning's value for the streams, because the Manning's value for the streams and for the overland are different based on the land use and land cover data set. So we need to assign the Manning's value using a shape file. So we need to generate that. So this tool will automatically create the buffer zone using the stream shape file. That's why we need to make the stream alignment. And then I'm giving that culvert because in the cut line shape file, that name of the location was saved as culvert. And work area, so that's the name of the work area, the boundary we saw, and the stream all are same. And here, what I want basically in this folder, I already assigned work area 2. So if I hit the button and I can see, it will just cleave everything, it will process, it will assign the refinement values. Either it's going to be 50 feet or 100 feet, and we'll have our shape files ready. So it created many shape files. And if you want to see what it has created, if you just import into GIS, go back and go there and see what are the layers we have. Let me select all, and it added everything there. Let me create a group out of it. And let me zoom out a little bit and see. I can turn off my previous layers so that you can see what we have. Yeah, there is no layer other than my study area. So it created a buffer zone even out of the study area is 5,000 feet, 1,000 feet. Usually what we do, we basically extend our boundary up to 1,000 feet. If you have multiple models to make a tie-in, in between different models, upstream, downstream. So that's why. But for this case, we don't need to extend the model, whatever boundary we have, we can still use that. So we don't need 1,000 feet. We don't need anything 5,000 feet. So we just need to use our initial boundary, whatever we have, and see the layers. It's basically created refinement region. This refinement region is empty here because within this boundary, there is no population, there is no cities, no town, no community. So it's empty. There is nothing. It didn't clip. If you have anything inside that, it will definitely clip and it would give you the refinement region, and we can use that region to refine our mesh in the second level. So for this case, we're not using that. And what we have convert file separately, cut lines. So we'll use that later on. The most important is stream refinement. You can see, let me just turn it off and give you the explanation what we have. So first go for this Manning's calibration region. So this is the boundary I just mentioned, 100 feet left side and 100 feet on the 50 feet on the left side and 50 feet on the right side. So that's basically giving you an option to assign the Manning's n value for the stream. So you can make it a little bit like narrow, that's okay. But to be on the safe side, I just use 50 and 50 both sides. And we have this polygon. So we'll import this polygon into our RAS mapper, and we can assign the curve numbers. We will already assign the curve number. We'll just assign the Manning's value for the overland, and we'll assign the Manning's value for the stream. So we already created those from our previous tutorial. We used a script that generate those curve numbers based on this combination of land use and soil data set. You can remember that. If you can't, you can go back and watch it again. And for the Manning's, so we have the reference values here. So these are the reference values, and based on our model data, we just have it here from the script. So now we'll just copy this one for the base means for everywhere, including channel and overland. And if you just assign for channel using the shape file we just saw, Manning's calibration region, then it will just replace the base value for the channel, but it will preserve the Manning's values for the overland as well. Okay, that's that. Now it's time to import this data set into GIS. Oh, because we already have it here, and then we can go back to RAS mapper. So we can go back to RAS mapper and we can just refine our mesh. Let me just do that here. So we already have our perimeter, and here in the infiltration layer, you can see we already have it. Manning's n, just turn on the Manning's n layer. You can just right click here, or you can turn it here on, and then go to edit Manning's n value, and you can see that list of land use and land cover. So we need to assign the Manning's data here. So just right click on it, edit Manning's n value. Is it in editing mode? If not, then we need to make it like editing mode. Okay, let me just save that mesh we created previously, and then it's saved. Let me put it into edit mode again. The geometry, yeah, so we'll have all the layers in editing mode. Okay, so we have the base value here. If you want, now we can just copy and paste, and here in the final values, even we can assign as well. So let's just override the base value, okay? Let me go back and copy. First, assign the base value. Let me, not here. Is it in editing mode? Yes, it looks like it's in editing mode. Yeah, I just use it here. It's done. Okay, in the infiltration layer, let me just check everything. Yeah, everything is okay in the calibration. If we need to change, we can just overwrite later on. That's okay. And here, okay. Yeah. So we just use those values, but we don't have our shape file, right? So what we need to do, we need to import. Just we assign the base value, but okay, let's import the shape file first. So it's in editing mode, import feature from shapefile the same way we imported our boundary. So go back to GIS and I processed this data previously. So in work area 1, work area, so I can just use, instead of using work area 2, because I just created and I didn't test if everything is okay, even though it will look like okay. So I'm just gonna select from these previously processed data so that it just create everything the way we want. And since it is showing the preview, that means it looks good. There is no error, no it didn't even omit anything that is incompatible. So everything looks okay. You can just import this layer. You can see, so that's the layer. So we'll have base n value everywhere, but we need to replace those base values following these streams. So here is the trick. If you just open again, and you can see that's the base value. And here we need to replace that base value from this part as channel and just paste it. So previously it was 0.04. Now we are using this. Okay, so click OK. And if you want, you can check. Yeah, that's okay. So we just assigned our Manning's value, and we also replaced the roughness for the channel as well. If you want, you can just, yeah, exit the edit. And let me just end my video here because it's going to be a long video. So in the next video, what I'll do, I'll use the roadway shape file, I'll use the stream shape file to refine the mesh from this nominal mesh. So we are done with generating different layers, land use, soil, and Mannings. So that was my intention to do here. In the next part of the tutorial, what I'll do, I'll just refine it. So thank you so much for watching. And if you have any question, you can ask the question in the comment box, and you can even download this data for the study of uh, like for the state of Texas, because I have those links, but you can just search for roadway, you can search for other data as well. It will be there and you can easily download. And if you won't be able to download, let me know. I'll send you the link. Sometimes because the links, they updates, and then you even won't be able to find the link. So thank you so much for watching and stay safe.